Hello and welcome back to another Physical Sciences 3 lecture. This time we're looking at Lewis diagrams or electron dot diagrams. Electron dot diagrams are often referred to as Lewis diagrams and are used to represent the sharing of electrons in molecular substances. A common feature of the Lewis diagram that you'll be asked to draw is that through the process of electron sharing, all atoms in the molecule achieve the stable condition of possessing the stable octet of 8 electrons around the atom. The exception is hydrogen, which usually achieves stable state with 2 electrons only. In the spaces provided, draw Lewis diagrams for each of the following substances. So C and Cl4. So you'll start to get familiar with these quite quickly, but carbon is in group 4, so it has 4 valence electrons. So just remember you can check this on your formula sheet. And then we have 4 chlorine atoms, and they all share one of their electrons. One of their electrons pair with the free chlorine. Carbon electrons. So we've got 1 chlorine for every one of the unpaired. So all of these form a stable octet of 8. And just notice that I've decided to draw the carbon electrons as crosses this time, and the chlorine ones as dots, just to show the difference, but they're all electrons. So it's up to you if you want to use crosses or dots. Just try to be consistent. If we look up F, we can see that F is in group 7 here, which means it's just like chlorine, it has 7 valence electrons. So we have an F atom here, and we have another F atom here, and I've already drawn in the dot for it. So they're sharing a electron each, so they're bonded that way. CO2, okay, so again carbon. This time I'm going to draw the carbon in the middle, and I'm going to draw the electrons this way. Carbon electrons, and then we'll have 2 here, and just remember the oxygen is in group 6, so it will have 6 valence electrons like this. Okay, there we go. So that pairs them all up, and nitrogen and bromine. If we look at them again. Okay, so nitrogen is in group 5 here, and then bromine's in group 7. So we have the nitrogen in the middle, and just remembering if it's got 5, then we have 5 electrons like this. Bromine, I'm going to draw these with crosses. It's in group 7, so there's 7 valence electrons. So they share those ones, and then there's none up there. Bromine here. Oops, cross. And bromine here. Sorry, my crosses are looking a bit like fish or something. Not quite like right, but anyway, those aren't the best crosses you've ever seen. But they're our electron dot diagrams, okay? Now we're just going to quickly look at naming binary covalent compounds. So binary means that there's 2 of them. So covalent compounds are made up of nonmetals. The nonmetals do not form ions. They share electrons rather than lose or gain them. They follow different naming conventions than ionic substances, which we saw were something like copper 2 sulfate or whatever it would be. And those kind of things, like we saw before for ionic, we use prefixes instead. And here are the prefixes. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, and so on and so forth. You're familiar with some of them. So like carbon dioxide means 1 carbon atom with 2 oxygen atoms, things like that. So carbon dioxide. So you are familiar with some of them. The rules to name binary covalent compounds are: the more electropositive element further left on the periodic table is listed before the more electronegative element further on the right. Okay, so electropositive is more likely to give electrons, or to donate electrons is electropositive, and the ones that are more likely to accept them are the further on the right. Okay. The second element is given an "-ide" ending, like oxide, and prefixes are used to denote how many atoms of each element are present. So, okay, so I spoke about a little bit like that before. Let's just have a quick look at some examples. So, for the chemical formula below, give the correct chemical name. So it's nitrogen is the first element here. So nitrogen is N, and there's two oxygens, so it's dioxide. Okay, so we don't need to worry because the first element only had one. We didn't have to put mononitrogen dioxide. It's just nitrogen dioxide. B, there's sulfur. Similar again, sulfur dioxide. This one here is phosphorus. Phosphorus tri for 3. So remember, you can refer to your prefixes up here. 3 is trichloride. D, again we have sulfur. And we have 4, so we can look up 4. It's tetra. Tetrafluoride. I always spell that wrong. Oops. Fluoride. Let me see how fluoride spelled. F-L-U-O. I always forget which one comes first, the U or the O. There we go. And what's the U? Always looks funny to me. Tetrafluoride. Nitrogen again. It's our first. You do get familiar with them. And then this is tri. I always think this is weird. Iodide. Nitrogen triiodide. I always butcher that pronunciation. Okay, so this time we have 2 nitrogens there. So this one will instead be dinitrogen tetraoxide. Oops, not texter. Tetraoxide. Okay, good. And we'll look at some forces in covalent bonding next time.